with our discussion of regression, particularly with nonlinearities and interaction, and using the trend function to make forecasts using regression. So if you live in a cold weather area, you're probably familiar with the wind chill index, which basically tells you, given the temperature in degrees Fahrenheit and the wind in miles per hour, how uncomfortable are you? For example, if it's 5 degrees out and the wind is if the wind speed is 5 miles per hour and temperature is minus 40 degrees Fahrenheit, then the wind chill index is minus 57.49. It's the measure of that. So it means it feels like it would be minus 57 degrees Fahrenheit with no wind. And the formula for this, I didn't know until recently, is 35.74 plus 0.6215 times the temperature minus 35.75 times the wind raised to the 0.16 power. So the larger the wind, the more negative basically the wind chill will be, indicating it feels like it's colder. Then there's an interaction term, temperature times wind to the 0.16. Now when temperature is negative, this is going to further lower the wind chill index. When temperature is positive, it would actually increase the wind chill index a little bit. Okay, so basically I put this formula in here in basically this regression worksheet, and these are the actual wind chill indices. And we want to use what we learned about nonlinearities and interactions to see if we can sort of reverse engineer this equation if we didn't know what it was. So we predict the wind chill here in column B using the data in column C. The temperature squared, the wind squared, that's the nonlinearity, and the interaction is the product of the wind times the temperature, which is the column F and G. So we can run a regression here to try and predict columns B from C through G, and whatever independent variables have high p-values will knock them out. Okay, so we go regression. So the Y range would be the wind chill. The X range is going to be all independent variables. We've got labels. Output range we can put right here is fine. I'm not going to worry about the residuals here. And so let's see what pops out here. Okay, got a great R squared, but let's look at the p-values. Temperature squared has a high p-value. We should delete it. These other p-values are like 0.120 zeros, 0.83 zeros. They're really terrific p-values. Okay, so we'd want to basically run this again and delete the temperature squared. Delete temperature squared due to high p-value. Okay, so we go to this worksheet. Okay, so we don't need temperature squared. We'll use columns C through F as our independent variables. Okay, so we're going to have the same regression window, I believe. So it's going to be, Y range should be column A, because I guess I switched this around a bit. Okay, X range should be not temperature squared, it should be C through F. Control Shift right arrow, down arrow. Labels, and then we can go, let's say, right here, and basically let's see what we get. Okay, everything is perfectly significant. Okay, all these p-values are incredibly small. Okay, and so basically the wind speed goes up. We're going to have a lower wind chill index there. We've got this slightly positive interaction there. And it's not the same equation as they actually use, but basically we're really accurate. The standard error is 0.89. Almost 95% of our forecast should be accurate within 2 degrees. And how could we create our wind chill from our formula? How could we chill out? Okay, we could use the trend function. So we go down to row 221, and it's an array formula, if you remember from our video on presidential elections. And so we do equals trend. Okay, now what do you put in? You put in the Y range, which is going to be the wind chill. And then the X range is going to be not the temperature squared, it's going to be these 4 columns. And I do Control Shift, Enter, and there is your forecast. Now, we can see we're just very close here with these forecasts. Okay, we got 37 instead of 36. We got minus 67 instead of minus 63. There we're off a bit. Okay, we got minus 40 instead of minus 41. And minus 71, we're right on there. And so we're pretty accurate here. So we've showed how we could use nonlinearities and interactions to reverse engineer a fairly interesting functional relationship in the world, the Windchill index, and use the trend function to make forecasts.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of three books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.